Today we present the final report to project about gender recognition. The team members, Jensen, Zelaya, Alfredo, Celso, and Enrique, Hernandez. The agenda is described to theoretical review for use to the finally to this project, how we did it, about how made the dissolution, the presentation to the application to solve this project. In theoretical review, for solve this project, was necessary to implement two algorithms, the SVM algorithm, system virtual machine, and the different kind, the Fourier analysis, specifically the Fourier transform algorithm. The system virtual machine is a good algorithm to the selection and analyze the different group, offset the sample to determine what is the probability to the close the best approximately to result in the study the different samples.
So why did we choose SVM algorithm? First, we were thinking about KNN, but when we were testing with our sample data, we came up that this SVM algorithm gave us the best accuracy. When we're testing the KNN for our sample data, using KNN we had like 93% of accuracy. But when we tested with SVM algorithm, we got a 100% accuracy for our sample data. So, and basically, SVM is another classification algorithm, which, as you can read in here, it uses the best hyperplane for SVM, which means the one with the largest margin between the two classes. So in the example in there, we can see that we have a class 1 in here and another class 2 in here. This is the hyperplane, and in this example, this is the one that has the highest margin. So this is how it classifies which belongs to which class. And well, also finally the Fourier transform is used to decompose the signals.
But the question is how we did it, okay? In the second last presentation that we did 3 weeks ago, we said that we will use some tools, for example, Matlab, MySQL database, and WAP5. But why the WAP5? Because this has a lot of more information that we can use to implement all the algorithms that we are using in Matlab. So this picture shows that we use the Matlab guides for users. This is the database, and this is some samples from WAP files.
So what we have done, actually this is the last version, the final version that we have for the project. Basically here what we can see is our time domain. This is basically what the user inputs. This is, let's say 1, 2, 3, 4, 5. This is in time. Also we have in here our frequency domain plot. Like the other group said, we have to find the lowest frequency in the whole spectrum of the recorded audio. And also, not just the lowest frequency, but the one that has a highest peak. from the lowest frequencies. And also in here we have the vector machine. So
And this is the sample of the database. We have the database, we are connected in the database in that machine. And this is the results that we have in the database, in the MySQL database. We have 19 web files with some information useful for this guide tools.
in here, for example, this is a test that we have right now. This is the one that we have running right now. And in here we can see, oh, by the way, in here we plotted the known values, which are the blue ones are the male ones, and the green ones are the female ones. So, and also we have also the red one, which is the unknown value. So in this example, we can see it was my voice. So according to the signal analysis, we determined that the gender was male, because according to the signal, we have to find which is this frequency in here. So for males, it's around, the pitch is around 50 hertz to like
164.
164. Yeah.
This is the frequency for male.
For males and for female is from 165, something like that, to 255.
250.
So in here, the application, what it does is tells you according to the signal, which is the gender, and according to the algorithm, which is the gender. So in here we can see that both are the same. The both tells us that they are males. And also in here we have the accuracy for this unknown value, which is 94. So right now we can
do a test.
we can do a test.
Somebody would like to speak in the computer, and we recognize the voice, and we are going to keep it on the database because it will be useful for the next test.
So this is the final application. So we need someone to record your voice in here. And,
One volunteer?
one volunteer.
Joanna, come on. Thank you.
So one thing that I want you to notice is that because we're actually learning from new data. Because what we do, actually how the program works is that it captures the data. It captures the data and process the signals. Then we connect to the database, and we have a algorithm which is trained with the database with the data that we know from the database. Then we create an object which is a trained object, and we apply this object to the unknown value. So right now, Joanna is going to be our
Tester.
Yes. So we will see that this value that now is known because we know that it's a male is going to become blue, and somewhere around there is going to be a new value, which is the value that we are looking for. So when I click, you have to see one click record, and you will see like a
Message.
that will tell you speak. And when it appears, you start to.
Okay.
Just to say your name, but in Polish it would be better.
Yeah, in Polish.
Yeah.
Okay. Yeah, it's appearing here. Wait. I guess that was another. Okay. So we have to see it here. Yeah, it records something, but the box appeared here, like in this.
So
Yeah, it will appear here.
Okay.
Yeah. Si quieres borrarte.
I'm going to erase the last record because
You see, the box appeared here. We were looking here where the box appeared here.
Okay.
So right now we're going just to delete this one because it's not correct.
Okay.
Yeah. So that's what in here.
Raz, dwa, trzy, cztery, pięć.
You see?
Yes.
Figure.
And we can see.
And we can see this is the new value, the known value. And actually the accuracy in this one is 100%.
I passed the test.
Yeah.
Yeah.
Now we are sure.
So we can try another one.
Mail.
Si quieres probar otra vez.
Okay.
Va a aparecer aquí en la pantalla.
Mi nombre es Alfredo, soy de Salvador.
The new one. So we can see here that in signal analysis we got mail, and in also the SVM analysis we got mail.
And the results are kept here in the database also.
So
Questions?
the database is always learning from the new sample.
Yes, yes.
So
We are
you
recording.
can try with this one. This one right now is spread. So we can try, for example.
For example, come here and we will check that this point will move.
Yeah, no, I've seen it before. I've seen it before.
Okay.
I just had this question of
Yes, yes, it
if
is.
the algorithm keeps learning.
Yeah, it keeps learning.
Okay, and this is the end of the presentation. If you have questions, observations, comments, we'll be thankful for us.
Thank you very much. I like the presentation.
Okay, thank you.